Hello dear viewers, welcome to this video lecture series. In today we are going to learn the storage classes. So let's begin with the table. Basically storage class define that how the storage is acting at the backend. So there are four storage classes. The first one is auto, register, static, extern. So these are the four storage classes. So let's take an overview about the properties. If I'm taking about the auto storage class, by default, if you declare any variable that belongs to the auto storage class. Okay, so now the storage is memory. Okay, so it's going to store the value in the RAM. And the second property is lifetime. It's local to that particular block. Let's suppose if I'm going to declare one variable in a main, I can access that variable only in a main. And scope is local to that particular block. You can't access it outside that block. And the default value is a garbage value, and you can use a pointer variable to keep track about the memory or to address that particular memory. Okay, so let's begin with a basic program structure. So okay, so now here I'm going to declare one variable, int a equals to 5. So now this variable is by default belongs to the auto class, auto storage class. Okay, so now let's see that what is the value of a. It's a very simple program. It's going to give me a 5 in this particular case. Let's suppose if I'm not going to initialize it, it's uninitialized. So in that particular case, dev.c will give you a 0. But if it's dependent upon the state of the operating system, and I can't rely upon this value because this will give me the garbage value. Let's declare some couple of more variables, and let's see what are their values. Okay, so I hadn't initialized b to 0, but it give me the 1. So you can't rely upon uninitialized value of auto storage class. It will give any random value, maybe in thousands, 32,000, maybe negative or positive. Okay, so let's keep it side by side. View, reading view. Okay, so the auto storage class, this ABC, all the values are stored in a RAM. So memory is RAM or a main memory. Now the lifetime is local to this block. Let's declare one function over here, void that function. So this is my function, and if I'm going to try to assess something beyond this block, beyond the main block, cout a, so I can't do that. That is not possible, right? As the property says that you can access these variable only in this block. Okay, so that's about the scope, and the default value is garbage value, memory is RAM, and the lifetime is local to this block. And pointer, yes, you can use a pointer. Let's declare one pointer int star p, and I can give the value, give the address of a, b, or any c to this pointer. Let me make this comment, and let's compile our program. And pointer, you can use a pointer with the auto variable. Okay, now if I'm going to write auto keyword in front of this is one and the same thing. Okay, this is optional. You can eliminate that. Without that, it is by default treated as a auto storage class. So let's move to the register storage class. Now in the register storage class, everything is almost same, but the memory is different. When you are qualify it with the register, so it belongs to the register storage class, and all the values are stored in the CPU register rather than a RAM. So whenever you want to deal with some variable which you need to speed up your program, then you can use a register variable. But mostly the integers or small values are considered for the register variable, because CPU registers are 16-bit, 32-bit, or 64-bit, depending on your computer architecture. Okay, So and the another thing is that you can't use a pointer to point to the register storage class. It's not permissible. uh, but here we don't have any error, so it's fine, but it's recommended that you don't use a pointer with the register variable. And one more thing about the register variable is that if CPU registers are not available, then the storage is used as a RAM. RAM is used as a storage in that particular case. So it means if your register memory is full, then your register variable is almost behave as an auto storage class. Okay, so let's move to our third storage class, that is external storage class. So just like if you're not qualifying this thing with the auto keyword, it is treated as an auto storage class. So similarly, when you are declaring anything without not within any block, like int a, let's take g as a global, fine. Int g, so now it's not belong to any of the block, so then these kind of variable are stored in a external storage class. They follow the external storage class property. The memory is a RAM. Okay, lifetime is a global. Whenever your program is running, its value will be there. And whereas if I'm going to consider the scope, you can access this G anywhere from your program. Okay, let's try this. Cout G. Cout G. So I'm accessing this global variable from different part of the program and from the different block. Now you can see there is no error in this case, and the default value is 0. Let's test this. I hadn't initialized the G to any value, so it means this is going to give me a 0. You can see it's a 0. Let's test some other more variable, G H U. All these values are not initialized, so all are giving me 0 in this particular case because it's from the external storage class, and the property says that default value is 0 if you are not initialized any value. So you can still use a pointer with it. And the last one is a static storage class. Okay, let's do one thing, that use a function to demonstrate the static concept. Okay, so now I'm calling this function from a main, and here I'm declaring int a equals to a plus 10. I'm adding 10 to the a. Now let's suppose I'm calling this function 3 times. Okay, and within a function I'm going to print cout a and then creating a new line handle. So now what you guess that what we will have in our output. So before guessing anything, let's see that what is this variable, and to which class this is going to be matched with. So I hadn't it's not outside the block, so it is inside the block without any qualification, so it means it is by default belongs to the auto storage class. So now in an auto storage class, so lifetime is a local, means lifetime is within the block. So now whenever I make a first function call to this block from line number 13, it says that int a equals to, okay, let's give some value because it will give me the random value. So I'm fixing this value to the 10 first. So it's 10, and then I'm adding, it's 100, is equal to 100, then I'm adding 10 to the 100. So 110 would be printed on the screen on the first function call. So now whenever I'm going to execute consume this whole block, the control is transferred to this line, and then I'm going to execute this. Now as control is leaving from line number 9, the a value of a would be vanish in that particular case because lifetime is local. You can say the value of a will die in that particular case. So similarly, I'm again making a function call from line number 14, and again the whole procedure is executed similarly to the previous call. And same with this. So it means I will get 110 in all three cases. 110, 110, 110. Okay, so now I'm going to make it static. So the first property says that it's similar to the auto. It's using the same RAM. Now here is a difference. The lifetime is a local in case of auto in a previous case, but here for a static storage class, the lifetime is global. It means whenever I'm going to initialize a is equal to 100, if I'm going to leave this block, the value of a would sustain in that particular case. So let's but write on this program. So first I'm going to make a function call to fun from line number 13. So it's called this whole code. Here is a static int a is equal to 100. Then I'm adding it 10. So it's 110. So 110 is printed with a new line. Then whenever I'm going to leave this, the value of a will remain in the memory. So now whenever I'm making this second function call, so this is a static storage class, so initial value was 110, so here is 110 plus 10, 120. 120 will be printed on the screen. Now third function call, 120 plus 10, 130. So 110, 120 and 130 would be on the screen. So this is how you can differentiate between the auto storage class and a static storage class. Okay, so regarding the lifetime, you can see that extern and static will share this property. Both are having a global lifetime, and whereas auto and register, these are having a local storage class. Okay, thanks for watching, and keep subscribed to my YouTube channel for the latest new videos. Okay, thanks.